Okay, last page of vector apps addendum, page 10. Number 7, a system of equations is, and they give us a system of equations. Reduce the system to echelon form using row operations. So let's start out by writing it in augmented matrix form, which is going to take the coefficients 1, 2, 3, 3, negative 1, negative 5, 3, 1, 8. Just to make it tricky and HL-like, they put a variable in for one of the coefficients. 3, 1, 8. And then on the right side, I'm going to put a minus 1, 7, and 16. Okay? All right. Now, we're going to take this augmented matrix form that I just wrote, and we're going to change it to echelon form by doing row operations. Okay? So basically, we want to eliminate these bottom three numbers. The way we're going to eliminate the bottom three numbers is we are going to take the top row and we are going to multiply it by -2, and then we're going to add it to the second row. So let's take the top row and multiply it by -2. We're going to get -2, -6, -6, and -2a plus 2. Okay? And then we're going to add it to the second row. So we are going to get, we're going to leave the top row the same. So 1, 3, 3, and a minus 1. And then the second row is going to be 0, -1 minus 6 is -7, and 1 minus 6 is -5. And then the last element is going to be -2a plus 2 added to 7. So it'll be -2a plus 2 plus 7, which is plus 9. Okay. Now the last row, we could eliminate the first element of the last row by taking the first row and multiplying times -3 and then adding it to the last row. So let's see what that looks like when we take the first row and we multiply by -3. It'll be -3, -9, -9, and -3a plus 3. Okay, now let's add that to the third row. So the third row is 3, -5a, and 16. So when we add the first elements, 3 minus 3, we get 0. When we add the second elements, -5 minus 9, we get -14. When we add the third element, a minus 9, we get a minus 9. And then on the right side, we have 16. And we subtract 3a, and we add 3, and so we'll get 19. We'll get minus 3a plus 19. Okay. So now we have almost an echelon form. The only thing left is to eliminate the -14. We could eliminate the -14 by taking the second row, -7, -5, blah, 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 and we would multiply that times -2. And then we could add it to the third row. So let's do that. So first I'm just going to copy the first row, and I'm going to copy the second row, -2a plus 9. And then I'm going to take the second row, multiply it by -2, and add it to the third row. So the first element will continue to be 0. The second element would be 0 because, -7 times -2 would be 14. Adding it to -14, we get 0. -5 times -2 would be 10. I would add it to a minus 9. And instead of a minus 9, then we would have a plus 1. Because we're adding 10 to a minus 9. A plus 1. I'm going to erase this line I put here. -5. And this is going to be a plus 1. And then last of all, if we take the last element of the second row, which is -2a plus 9, and we multiply it times -2, we'll get 4a minus 18. And then we're going to add that to the last element, which is -3a plus 19. And so we'll actually get a plus 1. Okay. And now we have it in echelon form. And now let's check what the next step is going to be. Let's see what they ask us to do. So we reduce the system to echelon form using overall operations. Now show that if a equals -1, the system has infinitely many solutions and find their form. Interpret this result geometrically. Okay, so if we put a equals -1, then do you see how the last row becomes completely 0? Okay, so that would mean the last row would be 0 equals 0, and then the z value could be anything, and you could have infinite solutions. Now, if you had a equals -1, so the last row when you have a equals -1 would become 0, 0, 0, so then we know z could be anything. Let's try plugging in a equals -1 to some of the other rows. So 1, 3, 3, and then the first row would be a minus 1, -1 minus 1 is -2. The second row would be 0, -7, -5, -2a plus 9. A is -1, so it would be -2 times -1, so it would be +2 plus 9, which would be 11. And then the last row would be 0, 0, and -1 plus 1, and we get 0 again. Okay? Okay, so if a equals -1, the matrix would look like this. We know that z can be anything. Now what about x and y? So we know that z could be t. We'll say that z equals t, because z could be anything. And then we're going to use the other two equations, which are x plus 3y plus 3z equals -2. And we also have -7y minus 5z equals 11. So instead of z, we're going to just put t. So we're going to have -7y minus 5t equals 11. So we'll know that y is equal to 11 plus 5t, and then y is equal to -11 sevenths. Oops. -11 sevenths minus 5/7 t. Okay, and so that would be the value of the y. Okay, and then we're going to find the value for x. So for x, we're going to take this equation, and then we are going to use the value for y and z that we found. So we're going to have x plus 3 times -11 sevenths plus 3 times -5/7 t. And then last of all, we're going to have plus 3z, and remember z is just t, equals -2. Okay. Now let's simplify the x value. So we'll have x minus 33/7 minus 3 times -5, which is -15/7 t, and then the last one is plus 3t equals -2. Okay, and it's getting very big. Let's try to compress this so that I have more room to do the rest of the problem. Isn't technology wonderful? Okay, so our x value, let's combine these constant terms, and then we'll combine these t terms. Okay, so we'll have x equals, let's see, -2 plus 33/7 would be -14/7 plus 33/7, which would be 19, positive 19/7. And then -15/7 t plus 3t would be 21 minus 15, which would be 6/7 t, and then we'll subtract it over the other side, be -6/7 t. So basically what we have here is we've determined x follows this equation, y follows this equation, and z is equal to this equation. Does this format look familiar? This is the parametric form of a line. Do you remember that? So actually, if we're going to discuss part B geometrically, what we could say is these two planes intersect and they meet in a line. Okay? All right. Let's move on to, or actually did I say these three planes or these two planes? There are three planes, and the three planes do meet in a line. Let's do part C. If A is not -1, then find the unique solution in terms of A. Oh, by the way, let's look at a picture of what it looks like when three planes meet in a line. They look like this. Okay, so what we just analyzed was three planes that met exactly in a line. Okay, now part C. In part C, it says, what if A is not equal to -1? Then find the unique solution in terms of A. Interpret this result geometrically. Okay, let's go back and look at our original echelon form equation with A still in it. It looks like that, okay? And now if A is not equal to -1, you can imagine that the last row basically has 0, 0, and then like some number which is not 0, and some number which is not 0, the identical number, right? Now let's write that into an algebra equation. We would have A plus 1 times Z equals A plus 1. Now we know that A is not -1, so it's not 0Z equals 0, which would be infinite solutions. Now we can just take both sides, divide them by A plus 1, and we would get Z equals 1, because A plus 1 divided by A plus 1 is 1, right? So actually we just found that in the case that A is not equal to -1, then we know that Z is equal to 1. Okay? And if we know that Z is equal to 1, that gives us new values for x equals blah, blah, blah. So instead of x equals 19/7 minus 6/7, we're going to go back and get values for x and y that contain the a values. Okay, and I don't think I have equations that still have a's in them. So I'm going to have to go all the way back to this equation and this equation. So let's start with this equation here. And we're going to use that to find the y values, okay? So, let's see. It's going to be the equation -7y minus 5z equals -2a plus 9. And back when a was -1, we just like calculated the number for the right side. But now we don't know exactly what a is, because we know it's not -1, but we don't know exactly what it is. So we're going to need to keep a there. Now we do know that z is 1 now, so instead we're going to have -7y minus 5 equals -2a plus 9. Now let's solve for y. So we're going to, let's multiply everything by -1 so that we have less negative numbers, so we have 2a minus 9. Then we're going to subtract 5 from both sides, and we'll get -14 here. We are going to, let's see, I'll rewrite it here. 7a equals 2a minus 14. Then we're going to divide both sides by 7. So we'll get y equals 2/7a minus 14/7 would be -2. Okay, and that is the solution for y. Let's find the solution for x. So the x solution would be from this line here. So it would be x plus 3y plus 3z equals a minus 1. And let's put in z equals 1. And let's put in y equals that and see what we get. So now we're going to have x plus 3 times 2/7a minus 2 plus 3 times 1, which is 3, equals a minus 1. So now we have x plus 6/7 a, what does that say, minus 2? Yeah, minus 2. So minus 6 plus 3 equals a minus 1. And now let's shrink this down so we can get a little bit more work done in the same amount of space. Okay. And so now we'll say, we'll subtract the a's to the right side. And so we'll have x equals, and by the way, negative 6 plus 3 is negative 3, right? So we'll say minus 6/7 for both sides. So it'll be a minus 6/7 would be a over 7. Negative 6 plus 3 is minus 3, so we're add 3 to both sides, and we'll get plus 2. And that's our equation for x. And this is our equation for y. And our equation for z, of course, is this one. So if you give me the value of a for the system, which would be something other than -1, let's say it's like 10, then I would plug in the 10 into the both places that have a's still, and then I would have a specific value for x, and I would have a specific value for y, and a specific value of z, and that means it would be a point. That would mean that our three planes intersect in a point. And what does that look like? It looks like this. Do you see the three planes intersecting in a point? Okay. Let's move on to the last problem, number 9. Alright, so we are going to find if and where the following planes meet. So we have 3 planes. We have plane 1, plane 2, and plane 3. And they gave us the first plane in a vector form that uses lambda and mu. And they gave us plane 2 in a similar form, except for this one they use the parameters r and s because you can't reuse the parameters. You have to create new parameters for each plane. And the third plane has the parameters t and u. Okay? And the third plane is given with the normal, all of them are given in that weird form where you're defining the plane with 2 vectors, direction vectors, which are contained inside the plane. Okay. Okay, last problem, problem 9. We have 3 planes here. We have plane 1, plane 2, and plane 3 given in vector equations, and they want us to figure out when the planes meet. Okay. Now, do you notice that the first 2 equations are given in a form where we don't know the normal vector? Well, actually, all 3 of them are. So I prefer to work in the Cartesian form because that's kind of what we're used to, and I think that it's easier to solve with the calculator also. So let's go ahead, and the first thing we're going to do is we're going to convert each one of these so that they use the Cartesian form. And the first thing we need for Cartesian form would be the reference point for each one, which is not a big deal. We have reference points in each one of these expressions, right? But what we don't have is the normal vector. The way you find the normal vector for this type of format is you take the 2 vectors that are within the plane. Remember that basically what they gave you 2 vectors that are contained in the plane. And then if you take the cross product of these 2 vectors, then you can generate a normal vector. And so if we have this normal vector and we have the reference point, then we can make a Cartesian equation for the plane. So let's do that. We are going to take each one of these. We are going to find the normal vector for each one. Okay? So for plane 1, we're going to take the 2 vectors, this one and this one, which are the direction vectors, and we're going to cross product them together. So we're going to have 3, 0, 1 cross product with 1, 1, negative 1. Okay, so let's see what we get. So, for the first number, we're going to have 0 times negative 1, which is 0, minus 1 times 1, which is negative 1. So we'll get negative 1. For the middle number, we're going to have 3 times negative 1, which is negative 3, minus 1 times 1, which is minus 1, negative 4. But we're going to negate that because it's the middle number, so positive 4. For the last number, we're going to have 3 times 1 minus 0, so it will be 3. Okay? Now for the plane 2, we basically have 2, 0, negative 1, and we have 1, 1, 0. And we're also going to cross product these together to get the normal vector for plane 2. So For the first element, we're going to have 0 times 0 minus 1 times negative 1, which would be positive 1. For the second element, we're going to have 2 times 0, which is 0, minus negative 1, which is positive 1, and then we're going to negate the positive 1 because it's the middle element. Then we're going to take 2 times 1 and get 2, and then subtract 0, and we get 2. Okay? So our second normal vector would be 1, negative 1, 2. Finally, we're going to take the cross product of this vector and this vector. Okay? Do you notice that this vector has a negative in front of it? So you could negate every single one of these elements, but it doesn't really matter. Even if this was positive or negative, it doesn't make a difference. Let's consider that this does distribute here, and this is equal to 0, positive 1, and negative 2. Just to show you that that works also. So I'm going to have 1, negative 1, 0, cross product with 0, positive 1, negative 2. For the first element, I got negative 1 times negative 2, which is positive 2, minus 0. For the second element, I have negative 2 times 1, which is negative 2, minus 0, but then I negate that, and I get 2. And the last element, I have 1 times 1 minus 0, so it would be 2, 2, 1. Now I'm going to write down the Cartesian equations for each one of these, okay? To do that, I do need the normal vector for each one. And the normal vectors for each one are listed kind of like as the position vector of the equation, okay? So I'm going to write those in green. So for plane 1, the position vector, the reference point for the plane is 2, negative 1, 0. And for plane 2, it is 3, negative 1, 3. And then for plane 3, it is 2, negative 1, 2. Okay, what am I going to do with these two vectors, the position vector and the normal vector? Okay, so let me show you what you're going to do. You are going to make it into the equation ax plus by plus cz equals ax1 plus by1 plus cz1. Okay? So this first one, I'm going to put 2 negative 1, I'm going to put the normal vector, which is negative 1, 4, 3, and equals negative 1, 4, and 3. And what am I going to multiply times each one of these coefficients? I'm going to multiply x, y, z, and add them all together. And I'm going to multiply the green position vector 2, negative 1, 0, and add them together. And now I'm going to simplify this expression here. Okay, how do I simplify it? It's going to be negative x plus 4y plus 3z equals, and then I'm going to simplify this. Negative 1 times 2 is negative 2 plus negative 4, so that's equal to negative 6. Okay. For plane 2, I got 1, negative 1, 2 equals 1, negative 1, 2. And then I'm going to put x, y, z. And I'm going to have 3 minus 1 times negative 1 plus 2 times 3. And now I'm going to simplify this one. So I get x minus y plus 2z equals 3 minus 1 times negative 1, which is positive 1. So 3 plus 1 plus 6, which is 10. Last one. Now I'm going to put the coefficients here, 2, 2, 1 equals 2, 2, 1. And I'm going to multiply times x, y, z. And I'm going to multiply here by the position vector, 2, negative 1, 2. So this one is going to be 2x plus 2y plus z equals 4 minus 2 plus 2, which is 4. Now what we need to do is we need to find a point, x, y, z, which satisfies every single one of these equations. Okay? Now, this is a job for a computer. Or, if you want to practice your echelon form row reduction, you can with this 3x3 matrix. What would the 3x3 matrix look like? It would look like this. -1, 4, 3, -6. The second one would be 1, -1, 2, 10. And the last one would be 2, 2, 1, 4. Okay? So if you did row reduction on this, you could figure out the solutions, but it would be awful because there's fractions and other things. So I prefer to do this on the calculator. What would you use on the calculator? Well, first you would press the button apps. And I'd like to show you on the calculator, but I'm having trouble with my calculator emulator on the computer because I'm not able to install the PolySMLT apps. And you could use the PolySMLT apps for this. It's a little bit easier than using matrices. So I would put it into apps, and then I would put it into PolySMLT, which is an app. And then I would select simultaneous equation solver. And on simultaneous equation solver, there's a screen where you can basically input this data here. So, and then once you input the data and press solve, then out comes the solutions for each one of the x, y's, and z's. Okay? So I'm going to show you how that works. Just showing you some screen snapshots because I can't show you the real thing. The only thing you need to input after you hit simultaneous equation solver is notify them that you are using a 3x3 system, so 3 variables and 3 equations. Okay? Hold on 1 second and I'm going to show you those. So basically the calculator is going to give you this solution here. It's going to give you a value for x, it'll give you a value for y, and it'll give you a value for z. And I will show you the calculator screens that you'll encounter as you do apps in PolySMLT 2. First of all, you're going to choose simultaneous equation solver, and when you choose simultaneous equation solver, it'll ask you what size of system you're going to use, and you're going to say, I want a 3x3 system, okay? So the 3x3 system means 3 equations and 3 variables, okay? And then you can put auto here for like how you want your answer, and the rest of it doesn't really matter, okay? Then you're going to press the next button, which is the button underneath the next. And then that gives you, this screen. This screen is like a giant augmented matrix, right? And it's 3x3, and then it's got the extra column here, which is the augmented part. And then you're just going to put in the 3 equation coefficients that you have found. So we found this equation, this equation, this equation, and we just type them all in. Usually when you hit enter, it'll go to like the next line and the next line. So you just type these in by hitting the numbers, negative sign, and enter. Make sure you use the negative sign and not the subtract sign. Once you fill this in, then you press solve. And once you press solve, it's going to give you the last screen, which is the solution screen. Let me see where it is. There it is. The solution screen shows you the 3 variables with their values. And let's say that they come out in decimal instead of fraction. If you want it to come out in fraction instead, all you do is click on this button that switches between fraction form and decimal form. Pretty cool, huh? And that's it for that problem.